8, lesson 2, unit 8, lesson 2. So factorial notation and permutation. So this is kind of the first big one in terms of permutations. Okay, so it says investigating factorial notation. Consider how many ways there are to arrange 6 different books on a side of the shelf. That's one of your questions from your homework. Use a fundamental accounting principle. We calculate 6 times 5 times 4 times 3 times 2 times 1. In mathematics, this product will be written as a simplified form called a factorial. So when you write something in factorial form, there's actually a factorial button in your calculator. It's an exclamation mark. Okay, it stands for all the way down to 1 from whatever that number is. So 7 factorial will be 7 times 6 times 5 all the way down. Okay, so without using a calculator, determine these. So we're just going to do these, understanding what they mean. 4 factorial means 4 times 3 times 2 times 1. So that one would be 24 for 4 factorial. It's in math, and then you go to stats. Probability, yeah, probability, thanks. Probability, math probability. Okay, this value here would be 3 times 2 times 1 times 2 times 1. So that would be 12. Oh, why did I write 6? 12. Okay. Okay, notice that 6 factorial will be written in a variety of ways. Okay, so they're talking about all these different ways you can write 6 factorial. 6 factorial is 6 times 5 factorial, or etc. Okay, because that's just like writing them with like an additional. Okay, that's all the way out. The first one, all the way out to 2, all the way out to 3, etc. The reason that's important is because we got to think about canceling. Okay, when we're doing some of these, we can cancel. So like the table right here shows us 6 factorial or 4 factorial. I'm going to write it actually a little bit easier. Is that I'll actually have it. Okay, 6 factorial is the same as 6 times 5 times 4 factorial, and we're writing that so that we can see it cancels. And so that we get 6 times 5 is 30, so seeing that products cancel. Now, some people prefer, which is a little bit tedious to me, but sure, you can write all the way out. And then you can write 4 all the way out, and you can see that all those cancel too. Whatever you want to do is fine.
So you have to write up the number.
Correct. Because you're going to cancel that one off. Right. Okay, so say express 5 factorial as a product in 4 different ways. So 5 factorial, let's write that in 4 different ways. Let's do the easy way, or the normal way, I guess. Then we do, let's do 5 times 4 times 3 factorial. We can do 5 times 4 factorial. Okay, and then we can do 5 times 4 times 3 times 2 factorial. I just kind of mixed it up there. This just helped me with the simplifying. Okay, we're just working on simplifying, looking at the patterns of factorials and how you can cancel and simplify those. Okay. Okay, 12 factorial written as 12 times 11 factorial. 8 factorial will be written as 8 times 7 times 6 factorial. Any questions thus far? Yeah, yeah. Wish we started with this one, right? Okay. All right, let's go ahead and do the bottom part here. Okay, express the quotient of factorials, 6 times 5 times 4. So they want you to write it as a quotient. So what they're saying is, if you have 6 and 5 times 4 left, what canceled? 3. Yeah, the 3, because the 3 is what the 4 is still there. Yeah, but 6 factorial or 3 factorial is the same thing. Does that make sense? How could you write 15 times 14 times 13 times 12? Yep, 15 factorial over 11 factorial. Okay, good. You guys are good. What's cut off, right? What's cut off is 11 down, so we divide it by 11. Does that make sense? Yeah. Okay, without using a calculator, simplify. So this one here. Okay, 90 times 8, 720. This one's kind of interesting. Okay, so what you're going to have is you have 8 factorial or 5 factorial. I'd go over the bigger one for your canceling. So what I mean by that is I know that I have an 8, 7, 6 here because I canceled the 5 off. And then I'm still over 3, which is 3 times 2 times 1. And I would actually just do that division. Or you could notice, what's 3 times 2? So that cancels that off. Your answer is 56. Either way is fine, though. The big one is just separating them. Like understanding the 5 knocks off the 5 down for 8. Okay. Because the 5, right? 4's under 5, right? Okay. All right, good.
So, if you break it all down, you break down 5 all the way to 1 and 3 all the way to 1.
Yeah. Yeah, and so you could do that, but I would always cancel the bigger number because it takes out more. And then the 3, like that small number, you could simply divide, or if you find something you can cancel, you can do that too. Like you simply could go 8 times 7 times 6 divided by 6 and get 56. That's fine. Like you didn't have to see that it was 6 and 6. Does that make sense? Okay. Okay, factorial notation. So now here's some notation in general. Factorials are written as n, n minus 1, n minus 2, n minus 3, etc. multiplied, which makes sense. The number previous, that's what this means. Number previous of that. Note that in the above definition of n factorial, n has to be a natural number. So we're not doing 1.3 factorial. Okay, so that's what we're saying. Natural number means whole numbers, right? So factorials won't be 5.5 or anything like that. Okay, which makes sense because what would you do? 5.5, 4.5? That wouldn't really make sense in terms of how you go down. So that has to be a natural number. Now, this is very important. 0 factorial is like kind of like the exponent idea. 0 factorial is 1. It's not 0. Okay? Okay, so the reason being is because if you do, it's kind of like the idea that if you do, gosh, I did a proof of this last year. Let me think about this way. Explain it. It's kind of like the idea of if you do a factorial over a factorial, you'll get everything to cross off, essentially, which would give you nothing left factorial, which is still 1 because it's same over same. So it's that same kind of idea of like division of exponents. But we can talk about that more. Let me see if I can pull up my proof of that, and I'll get that for you. Okay. Well, here you go. So it's coming later. So we'll talk about it later. Okay. So, for example, we already know that. This is all good. This is fine. We're good with this. Okay, let's get to these here. Okay, so n factorial is written as what? What would go here? N. That's basic, right? That's the normal one. Now here's a tricky one. N plus 2 factorial. We're just investigating the pattern. How would you write that? They want you to do 2 of them, and I can tell you why. What's the first one always? It's this. It's what's in here, the factorial. So it's going to be n plus 2. Then what's the second one? It's minus 1 of that, which should be n plus 1. And then minus that again is the n. So you're minusing 1 to n plus 2. You're minusing 1 to n plus 1. And then you get down to n. Okay. Okay, so this here, n minus 4 to n minus 5 to n minus 6. Okay, they're saying what factorial is this? Well, that's the start. So it's n minus 4 step factorial, because that's the first one there. That's all they mean. Okay. Simplify the following. Leave the answers in the product form when appropriate. So we have n plus 2 over n. So the way I want you to think about this is, I want you to think of this as simply the same thing as 8 over 6. As an example. Why? Because 8's 2 more than 6, right? And so 6 is going to cancel off all of them but 2. 8 times 7. So what you're going to have is, what's going to be left? The n plus 2 and the n plus 1. Because the next one would be n, right? And then that down is canceled. That's what's happening. I know this is weird because it's variables, but that's the understanding, is that this is 2 more than the bottom, so we're going to have 2 factors. Okay? All right. So this is a little bit tricky because which number is bigger, the bottom or the top? The bottom is. So we're going to have n's on the bottom here. Well, yep, but this is like n minus 2. So this is like, if, let's just say this is 6 minus 2 is a 4, right? 6 minus 1 is a 5. So you're going to have an n on the bottom. Yeah. So the point is, what you're saying, n minus 2 factorials on the top. We have n minus 1, and then we times it by n minus 2 factorial. And so then these cancel, because it's minus 1, right? What's negative 1 minus 1? It's a negative 2. So your answer for this one is 1 over n minus 1. Okay, yep.
Why is it the top n minus 2, n minus 1, n, and the bottom n minus 1, n?
So the top would be, if you did the top out, Ollie, it'd be n minus 2, n minus 3, n minus 4. You're minusing 1, right? You minus 1 to the group. The bottom, if we do it out a little bit, is n minus 1, n minus 2, n minus 3. So you see, this is where they pick up. They keep canceling all these. This is all that's left. But you have, because there's nothing up there, so it's a 1, yeah. What's that? For sure it does when you write all the way out. Yep. Yep.
So if there's a plus or a minus, you always are going down? Like between after the end, if there's a plus or a minus?
Well, if you're at a minus and I'm minusing more, then I'm getting a bigger minus.
Yeah.
But the pluses are still going down too, right?
Right, so they both.
Right, because we're minusing 1 to everything. Because the previous term or the previous n is always 1 less. For factorials, right, it's 8, 7, 6, 5, 4. So it's always 1 number lower every time. Yeah, every time, minusing 1. Yeah. So now look at this one. We have n times n minus 1. So there's no factorial on the bottom, so be careful there. But if I write this one out, it'd be n minus 1, n minus 2, etc., right? So then what happens is the n and the n minus 1 cancel, and so what's left is not just n minus 2, it keeps going, right? So n minus 2 factorial. What's that? Because the bottom's not a factorial, bud. That's just n times n minus 1. Yeah. Yeah. For n factorial, it's always n minus 1 because we always minus 1. So it's n, and then I minus 1 to n. So now it's n minus 1 to that, n minus 2. So if you start at n plus 8, it's going to go plus 8, minus 1 from that, plus 7, plus 6, etc. It's always minus 1 to the n. Yep. If it was a factorial on the bottom, where is the factorial? Is it on the n or the n minus 1? See, it's like those are two things.
So if it was on the n, it would make it n.
If it was on the n, it'd be just 1 over n minus 1, right? Because the n's would just cancel. Yeah. If it was on this, then I think it'd be the same thing. Yeah. So it'd be 1. What's that? No. Factorial is always declining. 8, 7, 6, 5, 4. Okay, algebraically solve this equation. So what they mean by this is you want to simplify. So I know that n, again, we'll start this pattern again. It goes n minus 1, n minus 2, and that's going to keep going. There's my minus, that's my factorial there. So that cancels. Now we're going to solve. So how many factorials? We've stopped the pattern. Okay? So that gives me, I'll wait. You guys are getting a little bit overwhelmed, it looks like. 2 to what? I'm going to, yeah. Right. Okay, now we're going to factor. Factors of 42 that are 1 apart. It's good, easy for me for touchdowns. 6 and 7. So your answer is a -6 and a +7. So we do get 2 answers, but based on our what did we say about factorials? They have to be what? Nope. No, not that either. We said natural numbers. Natural numbers are positive whole numbers, so -6 is rejected. 7's the answer. You're right that you got 2, Cash. You got to know which one to cross off. Yeah, and because that's a very good way of saying it, and then also it would be weird too because if we're going down and we're at -6, then we're going -7, -8, -9. The problem with those as well is that when you're doing a factorial, they're not negative ways, like you said, and then it's weird because it's flipping back and forth between positive and negative when you're multiplying, right? There's a lot of issues with negatives when it comes to factorials, so that's right. So we only have positive factorials. Okay. Right. You should, yep. So you plug 7, you should get 42. All right. Many calculators have the factorial key, which can be used to simplify. Go ahead and just try those in your calculator. What is 6 factorial? What is 9 factorial? All right. What do we get here? What's 6 factorial? Okay. Well, 9 factorial. 880, right? Okay, good. Simplify the quantity like 10 factorial 7 to 3 on a calculator. We can evaluate the numerator and denominator separately if you'd like. Okay, so what that means is you could do 10 factorial by itself and the bottom, then divide them. You could also just use brackets, and it's fine as well. For this one, I typically put my calculator, I'd go like this. Like that. That's how I put my calculator. The brackets? The biggest problem to do the brackets is because if you do it like this in your calculator, which a lot of people do, it usually divides it and multiplies it by 3. So you have to at least do that. Okay. So when you do it, though, you should get 120. Okay. Okay. And then again, to verify, get 120 again. Yeah, just they're all 120, however you put it in. Yeah. Well, it's multiplication. Yeah, so it's treated as multiplication. Yeah. Okay. All right, calculate the value of those. So you guys already got them. So somebody tell me what's 43 over 40? 74,046. Good. Which is kind of interesting, right? Because that's canceled off. You only have 43 times 42 times 41, right? It's pretty big for 3 numbers. Okay, how about the bottom? Okay. Good. All right. So we got the factorials down. Now we can do permutations. I think the biggest complaint that I've heard on these is when do I use permutations versus combinations? I understand the difference. So yeah. Okay. Internet site's access code consists of 3 digits. Knowing that 3 digits is not enough to access a site, the digits have to be entered in the correct order. The order of the arrangement is important. Okay, so permutations order is important. That's what we're thinking about, okay? John cannot remember the access code except that it contains digits 3, 5, and 7. List all the arrangements possible with 3, 5, and 7. So what are all the possible arrangements for 3, 5, and 7? So we'd have obviously 3, 5, 7, 3, 7, 5, We can go 5, 7, 3, 5, 5, 3, 7, 7, 3, 5, 7, 5, 3. So we have 6 possible options for arranging those. So there's 6 possible arrangements to consider, and only one of them will access the site. This type of arrangement, where the order is important, is called a permutation. So what you want to kind of circle here, permutation, the order matters. The order is important. Okay? So 6 possible arrangements. Again, this type of arrangement is called permutation. A permutation is an arrangement of a set of elements in which the order of elements is important. Okay? Are you guys good? Okay, so permutation of n, different elements taken n at a time. So we're just going to talk about these in general, and then we're going to talk about some letters down here. So list all arrangements of the letters for the word cat. So C-A-T. Whoops, let's get off highlighter here. Okay. So you got the 6 again. Write the number of permutation in factorial notation. So we got 6, right? 3 factorial. 3 times 2 times 1, right? Is what? 6. We have 3 letters. We have 3 letters. 3 factorials, how many ways we can arrange those letters? So there's 6 ways. Right. Okay, any questions on that? So we're going to stay basic with that, and then we're going to talk about distinguishable in a little bit. Okay, so Virginia. Okay, 1, 2, 3, 4, 5, 6. 6 factorial. 6 factorial. 720. There's 720 ways you can order that word, Regina. Okay, Kelowna. What is it? 7? 50, 40 combinations for Kelowna. 7 factorial. Okay. Okay, so now here we're starting to change it up a bit. So you guys got the basic part. We got factorials. We got the very elementary level of permutations. Now the parts you got to pay attention to. Okay, so permutation of n different elements taken r at a time. So it says use a fundamental counting principle to determine how many 3-letter arrangements can be made from the letters of the word graphite. How many 3-letter word combinations, I don't mean technically words, can be made from graphite. In this example above, we have found the number of permutation 8, okay, taken 3 at a time. So this is straight permutation. This is actually a button in your calculator. You're taking 8, and you're doing it 3 at a time. So it's 8 choose 3, is what we say. So this is how you put it in your calculator, but this is the calculation it's doing, okay? So here you go. Listen. Permutation. The P, that stands for permutation. It's in the same section. We're all in the same section. NPR. NPR represents the number of things you're taking, minus what you're taking. So if I have, this case, I have, 8 letters. 8 minus, I'm taking 3. So then it's 8 over 5 factorial. That's how they get 8 over 5 factorial here. Okay? Where's that? It's in the probability section again.
What does it equal?
56 times 6, so yeah, 336, or, yeah, it's 336 for that one. Okay, just the bottom here, you're verifying your calculator. Anybody need help finding another calculator? So what you do is just kind of like radicals. You want to type 8 first, then hit that P button, and then type a 3. Okay? Type the 8 first before you hit the permutation button. 8, permutation 3. 336. This is the formula the calculator is doing for you too, so understand that. That's what it's doing for you. Okay, we're on the downcline here. Last page. Questions? Yeah. Okay. Okay, here we go. Last page. Let's get the examples done. Okay, defining zeros. Here's the definition of 0. Okay, here you go, Aiden. If we place r by n in the previous form, we get the number of permutation of n elements taken n at a time. This is we know as n factorial. So npn would be n factorial over n minus n. N factorial over 0 factorial is the value of 1 because 0 factorial is defined by 1. So it's the idea that if we did a permutation of selecting the same exact number of things, there's only one way I could do it. That's what 0 factorial represents. So let me say that again. If I had 5 things you could grab, and I said, how many ways can you grab those 5 things? But all 5 of them. There's only one way. You grab all 5. It's done. So there's one way. When you go n minus n there, that represents 0 factorial, which stands for one way you can grab it. Okay? So it's 0 factorial because you're taking all the stuff one time. Okay? That's what. If there was one. Well, no, it'd be. No, it'd still be 1. It need to be 2. If it was 2 things, then there'd be 2 ways.
What if you had one thing? Yeah, what if it was?
Yeah, if it was one thing, that'd still be 1. It'd still be 1. Right, it'd still be 1. Yeah. Okay? All right. In a region, vehicle license plates consists of 2 different letters followed by 4 different digits. Got the license plate thing again. If the letters I, O, Y, and Z are not used, determine how many different license plates are possible. Do it from lesson 1 and then from today's lesson. Okay, so lesson 1, we would say, well, there's 4 things we can't have. So then it would be 2 letters, 4 different digits. Okay, so 22, 21 here, right? There's no restrictions on our digits. Okay, it says different digits and different letters. That means they can't be repeated. So it's going to be 10, 9, 8, 7. Okay, now this is going to be maybe what you'll think is the magic part here. So the permutation part. How many letters are we choosing from? And how many letters are we choosing from that 22? Yep. Yep. Okay, how many numbers are we choosing from, or digits? And how many are we choosing? Multiply those. They will be the same value. Right, if you make it into permutation. It's 2 million. $2.3 million.
What?
2.3 million. Okay. All right, so this one we have to use the permutation formula to solve. There's no inverse permutation or anything like that. Because it says we're trying to solve that algebraically. So we're solving for n. There's a missing n. And so what we have to do is we have to use the form. So if you go back to the previous page, we know the form was this, n factorial over n minus 1 factorial. Okay, that's what NPR is. Not minus 1, minus R, sorry. R. Okay, and so in this case, my n is n minus 1. And my R is what? 2. I'm simplifying the left side right now. Stay with me. I'm simplifying the left side right now. I'm solving for n.
Why n minus 1 minus 2?
Because see on the left there? Yeah. N minus R, right? Well, what's n? N is n minus 1. What's R? 2. So it's minus 1, minus 2. This right here is the n minus R. We okay? Okay, so now what that is, we simplify that. N minus 1 factorial over n minus 3 factorial. Okay? Now, do you see the top is going to be n minus 3 factorial like that? So these cancel. So now you have it so that you can solve. N minus 1, n minus 2 equals 90. And now you just want to FOIL that out, and we want to try to factor it. Okay, oh, who knows factors of 88 that are 3 apart? It's pretty easy. 11 and 8. Good job, Bobber. Good guess. What does that mean again? Okay, so n is negative 8 and 11. But we decline negative 8, right? So how you could check this? How can you check it real quick and then we're done? You're 11, yes. Put 11 right there. 11 minus 1 is 10. So 10 permutation 2 should equal 90. 10 permutation 2 should equal 90 is how you can check your work. Okay, and that's it.